Hey everyone, welcome back to the channel. I don't think this is new to any of us. Machine learning is all around us, and that's fantastic. However, we often just think of the algorithm, whether it's like a logistic regression classifier, a large language model such as GPT-4. We tend to only focus on the algorithmic part of that whole solution. But the algorithm is only a small part of an ML system. And there's an entire system put around an algorithm in order to put it in production. And this is what we call ML system design. So today we're gonna kind of have an introductory video on this concept of ML system design. And then in future videos, we'll go deeper into the various parts that make up an ML system design. All right, so let's dive in. All right, if we look back over the past 10 years, it's pretty hard to believe the progress that we've made around ML. 10 years ago, ML and AI were not serious, widespread career options, really. Rather, it was more preserved for academic research or more R&D organizations. Fast forward to today, and we find that ML is being injected all over the place in every part of our day, whether it's personalizing our shopping experience, getting our next movie or product recommendation online, logging onto our phones or other apps, using maps to get us to our destination, or rerouting us when there's an accident that's going to delay us. And the list goes on and on. So organizations continue to find more and more applications of ML and how they can apply it to better serve customers and also themselves in trying to make their organizations more efficient and cost productive. Yet there's a lot of opportunities that exist still for ML to be injected in organizations or in our day-to-day lives. Fields such as healthcare, transportation, farming, restaurant automation. This is just a few of the examples where ML is just starting to get injected into those industries. But to make ML work, we need to think about it more than just as an algorithm. In fact, to operationalize an algorithm, we need to put it into production, which includes deploying, monitoring, and maintaining it. We often use the term ML ops or machine learning ops to talk about this productionization process because it refers to the set of tools and best practices for bringing ML into production. But there's even more to it than just ML ops, because we also need to consider stakeholders along with the business objectives and requirements. And so that's why this more holistic picture that we need to think about is referred to as ML system design or machine learning system design. So ML system design is a process of defining the interface, the algorithms, the data, the infrastructure required, the hardware for machine learning systems to satisfy specified requirements. And the specified requirements part of this statement can generally be summarized into 4 requirements. Reliability for the ML system, the ability of that ML system to scale as necessary, the maintainability of the ML system, and the ability of the ML system to adapt as changes occur in the data or the business requirements. We'll talk more about these requirements later on, but just realize that these are the 4 fundamental concepts that should be at the top of our mind when putting an algorithm into production. All right, so why is this important? Well, unfortunately, the algorithm is usually the non-problematic part of an ML system. The majority of reasons why ML systems fail are because of the non-algorithmic parts of that system. So a presentation given by Google found that 63% of failures in a major ML system dating back to a decade ago were driven by non-ML components in that system. Only 25% of the failures were driven by the algorithm itself. And one of Google's big recommendations is that organizations should focus less on acquiring staff with very specific, specialized knowledge on the algorithm part of machine learning and focus more on building more breadth in knowledge of the entire ML system. So I'm guessing that's kind of why you're here and you're watching this video, because you want to become a stronger generalist in the idea of productionizing ML systems. All right, before we wrap up, let's kind of talk about setting expectations. So we don't turn into machine learning engineers overnight. This takes a lot of experience, a lot of iterations. We don't create groundbreaking technology in one fell swoop, okay? So rather, we iterate and we build up small capabilities over time. The first iteration, which we often refer to as like a minimal viable product or MVP, is often pretty buggy. A great example is this Stalker AI camera. where the objective was to automate the camera tracking based on the soccer ball. However, the camera constantly mistaked the referee's bald head for the ball. But you know what? Companies produce products like this all the time. The MVP is going to be buggy, it's not going to work that great, but bringing the system to life with an MVP and with demos allows them to start to see the value in the system. And once they see the value, once that value is obvious, then they want to iterate as fast as possible, improve upon it, and generate a polished ML system that's going to generate the value. Okay, so the same approach should also be your objective in becoming an ML engineer. Learn some foundational concepts, identify ways to create a small MVP with those skills and that knowledge and put it into practice, and then iterate. Continue learning more, refine your skills, and refine the implementation that you did previously. Do demos to show other folks what you're doing. And over time, you'll become a pretty darn good ML system designer. All right, so that's a wrap for now. Hopefully you now have a better understanding of why we need to think about ML from a system design perspective. So in future videos, we're gonna kind of build on this knowledge and dig a little bit deeper into the different areas and concepts that make up a machine learning system. So until then, happy learning, and don't forget to like, share, and subscribe for future tech tutorials.